Hello and welcome to my new technical video about my Jobo CPE2 processor. In this video I will step up from my prototype to better solution and make it more easier to modify in future. So I bought few components and let's start unpacking and check what I have. Just in case, I bought few switches with the caps because I really like the mechanical switches like this. And my intention actually use it to switch off the lights and backlight on the device itself. Still not sure how I'll do it, we will figure it out in future. Second most important thing, it's actually connectors for the Jobo CPE2 to my external auxiliary device. I bought these aircraft style connectors with the 4 pins. And practically for this modification you need only 3 pins, but anyway I bought it with the 4 just in case if I need additional setup or I need to change anything inside. For my assembly I will use this gray box. Unfortunately I don't have the black one, it was not in stock. So for now I just bought the gray one and it looks relatively nice. The size looks nice and I will mount it directly to the front panel and it will basically stick inside this box. Now I will disassemble what I created before and make a lot of tests, test fits and figure out how to make it better and looks better in future. So far it's anyway prototype and I don't really have a lot of good devices and a lot of good tools in my apartment. So it will look a little bit more crude than I usually do at work. So the size of the box looks fine, because inside the box I have pins for mounting the PCB. But even with the box inside for temperature control, it fits inside quite snugly and without any problems. So let's remove the cable from the connectors and start the assembly of the device itself. First thing what I want to figure it out, actually what is inside this box, so I want to disassemble it and check if I can simply cut off with the switch power supply from the screen. As you can imagine, this temperature control device, it's completely total Chinesium and it's 10 euros only. So I'm completely not expecting anything quality wise from this type of devices. What I want to find in this assembly actually powering pin for the matrix screen. But unfortunately it's not so easy because all of the controlling components actually hide behind the screen itself. And this is cheapest PCB what you can imagine, and it's almost without any notations on the silk screen, so it's not easy to understand how it actually works. So I will proceed with the modification of the Jobo. An idea what I want to make is basically sleeper under the hood. So I want to make auxiliary exit for my controlling sequence and keep the whole device intact, which can work completely as normal device without any connections of auxiliary devices. So first of all I will disassemble what I made before and cut off the cables what I made before and bring up the device to initial state before modification. It's relatively easy to make and I will put back this simple temperature control switch because first of all I don't want to ruin it, and secondly I want to use the device in time when I make future modifications for the auxiliary box what I will create. As you can see inside, it's not really a lot of free space for my connector and for the cable management. It's quite huge space inside and a lot of space is just wasted, mostly because it's retro technology and PCB itself is just huge. So I first of all try to think if I can fit it on the left side and if I want to fit it on the left side or if I want to fit it on the front side. Nevertheless, the front mounting looks fine, but I want all the connectors or look as it should be from the factory. For example, you can mount it on the front panel or just put it behind. So let's remove the PCB board and check what space we have behind the box. I will start with the assembly of the cables, probably in future for swap kit if anybody needed. I will create a PCB which you can easily install inside and make all the connections much easier. Unfortunately, in my apartment I don't really have a good soldering iron, so I will solder with the gas iron, which is a little bit overpowered for this type of applications, so I need to be really careful to not melt down all the connectors. And also, this crimp tool and the crimp connections, probably not the best idea ever, and I'm for sure doing it a little bit wrong. And the size of the cables probably a bit far off from the specs. But for second prototype it looks fine and doesn't create any type of different problems. And now I'm looking on this setup, I'm just thinking about the connecting the pump with the same way as connecting these auxiliary cables. Because I will always use a pump no matter what, it's actually a really good idea to connect it directly to the power supply of the tool and keep it there forever. And these external cables and connectors, really good idea if you want to replace the cable or make it bigger or just choose the different length or the material. I really like the idea of second prototype just because it gives me more flexibility in future modifications, and I don't really need to disassemble the Jobo CPE2 anymore. And also style of these connectors looks almost the same age as a whole tool, so it doesn't really look artificial and it doesn't really look like USB-C on the old device. So I usually make a lot of test fits and just see how it looks like, how the cable looks like, and if I really like the whole assembly or not. So from this video I cut off most of the diggling with the cables and putting back and forward and just take a look how it feels and to bring out the final assembly. So I decided to not mount it on a wall, I just decided to drill a hole in the back side, because I have a better space and it's much easier to drill a bigger hole there and wrap the cables around the transformer. So let's start drilling and figure out the fitting of the hole. Unfortunately, I don't really have a tools like a Dremel or something useful for this type of applications, so I will improvise on the fly and try to fix problems if I have it. So I have drilling bit which is not enough in size, so I need to widen the hole a little bit and make a snug fit for the connector. So this is middle version of my connector what I have, and I test this type of fitting and if I can put the old cables behind the PCB and just connect it from the kind of a back side of the board. It's not really easy to put all the cables inside this small hole and put the actually fitting cup from the opposite side. But so far it looks nice, so I don't need to modify it in future, so let's keep it like this, at least for now. This type of aviation connectors also have a safety cup, so it's much easier to close up if you don't use this connector. And because it's simple wired connection and I don't really want to use any type of PCB because I don't really have any surface inside. Because for now I don't really want to use any type of PCB, I will just make additional connectors for more auxiliary devices. So I needed two connections after my power switch. The first one goes to the temperature control module and second one goes to the pump. And I create two more connections to connect the pump to 220 volts. And in previous videos, as you can probably see, I have a hole in the side of this control box because I removed one of the pins which used to hold this box on top of this vacuum formed frame. And this was idea why I bought 220 volts pump for the fountain to just mix around my water inside the water bath. So in principle, if you turn on the power, you will turn on the heater and in the same time you will turn on the mixing of the water. And I just realized you don't need to overcomplicate stuff to create additional switch to turn on or turn off the pump. Because pump in general works all the time and I don't see a reason why I need to turn it off. And even if device is empty, you kind of cannot turn it on. It's even written in a manual, so you will always use device with the water. Probably better idea to make a good connector for the pump and drill additional connector hole from the backside. but I think this power pump will last almost forever because it's a brushless motor and it's quite good, and I don't think I will have any problems in future. But even if I have this quick connection and disconnection, so I don't need to solder anything, I just need to throw away the pump and install the new one. So at the moment I have all the devices connected after power switch, so it's basically killed if I have no power on the device. It doesn't matter if I plug it on the wall or not really, because the switch disconnects the positive and neutral side. So now device became a little bit more safe for use, and you don't have running 220 volts from the power wall constantly all the time. And at the same time, your control for temperature also works without any problems. It's only one difference: you have this connector for auxiliary devices from the back side. So you have a positive and neutral connector there, and the basically additional hot wire and the control wire. As I said before, you don't need additional positive wire because you anyway have it from outside. So for now I just want to test if the device works without any auxiliary connectors. And as you can see, if you flip the power, you have a water pump, and if you add the temperature starts running and you have a switch fully working and works perfectly fine. So device in general became almost like stock device. So I can assemble it back and forget about all the modifications what I done to this device, and the rest of the things will be actually connected to this auxiliary device what I make in future. And cable management for the pump is also important, so I will hide it behind this leaf on my bath and just temporarily glue it with a hot glue. I'm still trying to find the easiest solution how to kill the light for the screen, but unfortunately it's not so easy, and I'm not really sure if I can do it with the one switch in the same time and do not kill the regulating circuit for the whole. So for now I will just keep it how it is, and in future I will probably buy the different one anyway. So let's continue with the creation of the back side of the board and mounting the auxiliary entrance for my auxiliary device. So I need to make a termination connector with the cables and make a good cable connections and cable management. To finish up this project, it actually took several days. So it's much better to enjoy it in a good company and make a lot of breaks to not overpower your ability to think and make things careful. So on the next day I finish up the connector and make it a little bit better looking. So my advice for this type of projects: make change and move slowly. So make a small iterations, switch a little bit directions, go and make some photographs, print some prints, and go back again with the new ideas. And make a front mounting for the temperature controller. I will try to put it in the middle of this control panel. And for me it looks so funny because at work I have 5 professional different lasers, and you can do exactly the same work in around 10 minutes and it will look precise and nice. So do not overestimate your ability to downscale and downshift your projects, and also do not overestimate your ability to step it up and make it with the crazy cool and expensive tools. But as I said, this is more DIY project, and probably in future where I will know what exactly I want to do with this type of modifications, I will make better version and move it slowly but firmly with the iterations and make progress with each step. So the fit from the first panel looks fine, and let's assemble the box again and put the temperature controller inside the front panel. I have 2 options where I can put the temperature sensor from the front panel and it will probably look a little bit ugly, or I want to put it from the back side. And I decided I will just drill a small hole on the back panel and create a small opening and feed the cable through the hole. This is simplest way to do it, and it will look a little bit more nicer if all the cables goes from the back side of the controlling box. And because the cable is black and the hole is also black, it's much nicer looking box in general. So let's make a final fit and check what's the cabling management, what I need to do inside the box, and how the temperature control sensor looks like. So far it's really nice assembly, and I really like the first result of this step-up box. And additionally, I can modify it and even keep the same box working and create a second box with a version 2. So for now I will connect all the cables in the proper manner. So now I need to correctly terminate the cable from my auxiliary output. So I have 2 cables for the power supply for this control box, and I have one live cable and second output live cable. And they both basically goes to the positive side of my heater. And now let's check the final functionality of my device. So if you turn on the power supply, you have a mixing of the water, and the water pump works perfectly. The connection goes inside and you even don't see the cable. At the same time, the safety switch for overheating also works. And the main old type of temperature control also works without any auxiliary devices. If you flip the motor also works without any problems. But in the same time you have this auxiliary device output, and if you connect your cable to this type of connector, you have a full control for the heating element inside this device. And when you connect this cable, you just need to connect opposite side to your controlling box, which looks like this. So you have a back side and the front side. You have a temperature sensor control with the temperature settings, deviation, and so on and so forth. On opposite side, you have an output of the temperature probe and the connector. For example, you can store it here behind, or you can put it on top of the device. It doesn't really matter. You just connect the box with a cable, and I personally decided to put it on top of my Jobo CPE2 because I don't really have a lift and I can put it here temporarily. And I will fix this box with a double-sided adhesive tape, and like this it will be much easier to disassemble it and remove it from the assembly, or put the different types of box on top and makes different types of experiments. In your future, I anyway need to disassemble everything, put it in the boxes and transfer the whole darkroom to the new place. So it's quite handy that I finish up this project and I can disassemble it fast enough. And now let's check the functionality with my auxiliary box. So you turn on the power and you have a power on this temperature control switch. And as you can see, it's already heating up because the settings inside this temperature box is saved. I don't need to think about to put it to 35 degrees back and again, or 38 degrees if I actually develop C41 cell. What is crazy important about this box, you have an external temperature control which you can put inside the bottle and control the temperature exactly for the chemicals. So this setup allows you not only measure but also control the temperature and all temperature losses on the bottles, so you don't need a back and forward go with the temperature controller. So it's increase the stability of temperature of the whole chemicals, and you can be sure that your 38 degrees is exactly 38 degrees. And that's it for today. Thank you for watching and see you in the next videos. Bye.